All right, let's get into it. Today, we're going to break down the absolute bedrock of how pretty much every modern app handles its data. We're talking about the big three: SQL, databases, and the powerful systems that make them all work.
I mean, really think about that for a second. Every time you like a photo, send a message, add a friend, all that information gets saved, managed, and brought back in the blink of an eye. How? Well, it's all thanks to a brilliantly organized system, and we're about to pull back the curtain and see exactly how it's done.
So here's our game plan. We'll start with the container itself, where the data lives. Then, we'll look at the super smart system that keeps it all organized. After that, we'll learn the language we use to talk to that system. And finally, we'll see how all three of these pieces snap together just perfectly.
Okay, let's dive right in. At the very heart of all of this is the database. It is the absolute foundation, so let's make sure we have a crystal clear idea of what it is.
Now you really got to focus on two words here: organized and managed. This is not just some random junk drawer of files on a computer. A database brings order to the chaos, and that's what makes the data inside it so useful and reliable.
Seriously, this is the best way to picture it. Just imagine this giant filing cabinet that holds every single piece of information for a whole company. But it's all digital, and it's indexed so perfectly you can find anything in an instant. So, how is this digital filing cabinet organized? Well, it doesn't just throw everything in together. If you look at this school example, you can see it uses separate drawers for each type of information. In the database world, we call these tables. So you've got one table for students, another for courses, and so on. Keeping things separate like this is absolutely crucial for efficiency. So having an organized cabinet is great, for sure. But what good are all these separate drawers if the system doesn't understand how they connect? That's where the next piece of the puzzle comes in. This is the software that actually runs our digital filing cabinet. It's called an RDBMS, or Relational Database Management System. And that R for relational, that's the secret sauce. That's the real brains of the whole operation. Now, to really get this, you just need three simple terms: tables, rows, and columns. Sticking with our analogy, a table is like a whole drawer. Let's say the one for students. A row is just one single file folder inside that drawer for one specific student. And a column? That's just a piece of info on the folder's label, like name or student ID. Easy, right?
But here, this is where the relational part gets so incredibly powerful. Those different tables, students, courses, grades, they aren't just sitting there by themselves. The system has to have a way to connect them. I mean, how does the grades table know which grade belongs to which student in the students table? Well, it's not magic, but it's pretty darn clever. It uses special links called keys.
And this just explains it perfectly. Every single student gets a unique primary key. Think of it like a social security number that can't ever be repeated. Let's call it their student ID. Then, over in the grades table, you just write down that same student ID next to a grade. That's the foreign key. It's this simple but brilliant system that builds these rock-solid relationships across all of your data.
And believe it or not, this revolutionary idea has been around for a while. It was invented way back in 1970 by an IBM mathematician named E.F. Codd. What made his model so genius was that it separated what the data was from how it was physically stored. This let developers stop worrying about the hardware and just think about data logically. It's the foundation for almost every major database we still use today.
Okay, so we've got our cabinet, the database. We've got the smart system organizing it, the RDBMS. But now, how do we actually talk to this thing? How do we ask it to find info, add new stuff, or make a change? Well, for that, we need a language.
And that language is SQL, which stands for Structured Query Language. You can think of it as the universal language for talking to relational databases. If you're going to work with data, you have to learn to speak SQL. It's that simple.
You know, the real beauty of SQL is that it's a declarative language. Now, that sounds fancy, but all it really means is you don't have to tell the database how to do its job. You just tell it what you want. You just say, hey, get me all the students who have a grade above 90, and the super smart RDBMS figures out the most efficient way to go get that for you. You just ask, it delivers.
Honestly, most of what you'll ever do in SQL comes down to these four basic operations, known everywhere as CRUD. That's create, read, update, and delete. These four commands, they are the backbone of almost every single app you use. Let's take a quick look.
So, to add a new student, you use insert into. That's just you telling the system, hey, make a new file folder and stick it in the student's drawer.
To get information back, you use select. This is the one you'll use all the time. It's basically you asking, can you show me all the files you have in the students drawer? Now let's say a student moves. To change their address, you use the update command. That's like telling the system, go find this one student's folder and change the address on the label.
And finally, to remove a student, you use delete. This is your command to find this folder and get rid of it permanently. As you can imagine, it's powerful, so you use it with a little bit of care.
Okay, so we've looked at the 3 pillars one by one. Now it's time to put it all together and get that final complete picture of how they all work together in perfect harmony.
So let's just boil it all down. 1. The database. That's our filing cabinet, the container. 2. The RDBMS. That's the intelligent system that organizes the whole cabinet and understands all the relationships. And 3. SQL. That's the simple language we use to give that system commands. These 3 pillars work together to literally power our digital world.
And there you have it. From your social media feed to online shopping to huge scientific research projects, this trio is always running behind the scenes. Now that you understand the basic architecture, it really does open up a whole new world of possibilities. So the only question left is, what are you going to build with it?